I know that I've written off parts and I'm not proud of it because I didn't do my due diligence. Let's talk about hydraulic holders. I know when they first started coming to the industry, there was a big learning curve, at least for me. The first time I put one on the shop floor, I had it set up, it was running good. Someone went to change the tool. For some reason, they decided it was a good idea, to fully clamp that screw and explode the membrane. The good news is that they've been in the industry for a while. So they have continued to re-engineer and reinvent to increase the holding power, reducing and eliminating the pullout, as you'll see in the videos, depending on the manufacturer that you choose to invest in. Let's check out some head-to-head competition footage, courtesy of Sandvik Coromant. All right, so you're gonna see 3 different holders run in 2 different typical sizes, your standard as well as your slim line. Let's see how it goes. Oh, look at that. There we go. Sing me the song of your people. Watch that spindle load. Okay, it's done. Here we come in with the competition. Here we go. Watching that spindle load again. So this red line right here above my head, they're indicating the amount of pullout. I love that they include the machining sounds because the sounds tell a lot. The curious and interesting thing here is if you notice the spindle load, but look at that pullout. You can actually watch it pull out in that zoom in. Great work with the video too. Right here. Check out that different level of pullout that's been present. Competitor B, that's nearly 400 thou. That's over 9 mil of pullout. Competitor A, 3 mil and about 1/8 of an inch. Still makes a world of difference. And then you've got the 930 chuck. They're saying 0.02 millimeter worth of pullout. So they're definitely running this against the wall. Let's check out the next side. All right, we've got the slim line. Singing all the glory. There's that spindle load. You can watch the pullout again in the zoom in window. Here we go again, watching that spindle load climb and watching that pullout creep. And again, spindle load and the creep. Creeper's gonna creep. And then you see again 0.01 mil pullout for the 930 chuck, which is less than the full holder, 0.33 in the competitor and 1.7 in the other competitor. It's crazy the amount of pullout that's there. And of course, this would scrap apart. And you might be thinking, okay, Arthur, but what if we're not actually planning to run that full depth of cut? Well, yeah, you could totally see the performance in the output, see that your tool's pulling out, modify your parameters, go to some different styles. But this is a demonstration purely for the retention force purposes of these holders, combining the retention force, the machining forces, and then all of those vibrations that slowly eke things out. It's always nice to see some competitive footage to really demonstrate what they're talking about. And it's here, plain as day. I know that I've written off parts and I'm not proud of it because I didn't do my due diligence when it came to selecting the right holder for the job. And that's a lesson I could do without ever learning that lesson again, to be honest. So I'm sharing options with all of you as we continue to push our end mills harder and harder in the world of manufacturing. Having something that's actually going to hold it in is going to make a big difference. As always, my goals keep your spindles turning and earning as much as possible. Until next time.